Hello and welcome to this webinar, A Journey Through Security Maturity. This is the third and final part of this Splunk Security series, and we'll be picking up from where Ben left off, taking a look at years 5 onwards and what you should be looking for from a security operations perspective at this point. So my name is Stu Lowe. I've been working with Splunk for a few years now, particularly with Splunk Enterprise Security and Splunk SOAR. So today, as well as discussing security maturity, I'll be aiming to show you where Splunk SOAR fits in the security maturity model, and also give you a quick glimpse of some of the more advanced security detection features that are available on the Splunk platform. Okay, yeah, and as before, quick webinar plan. So I know Ben has discussed at depth security maturity modeling, and so we'll park any further discussion on the broader aspects of this today. But I will be continuing on to the next stages of the Splunk security data journey, and look at the kind of maturity levels we might typically expect a security operations team, for example, to be operating at 5 years onwards. I'll then take a look at how Splunk can help you move forward according to this model, and take a look at some of the tools that are available to help us do so. And yep, Ben's talked through this one. So here again, we can see the capability maturity model. So these are the 5 stages that we might typically expect to see in organizations' processes progress. So from the ad hoc there on the left and disorganized, all the way to operating with well-defined, honed processes, which they'll constantly be seeking to optimize at level 5 there. So it's at this 5th level, optimization, that we'll be taking a look at today, and in particular some of the tools we can use to continuously improve the managed, monitored, and particularly important for optimization, measurable processes that we've developed at level 4. And security maturity then. So very briefly, generally as well, it is the mapping of an organization's security posture against its business requirements. So if you understand your own security maturity, you'll better understand the risks to your organization, and so therefore allow yourself to focus on how you can enhance your cybersecurity posture. And how to progress then. Okay, so how do we progress from the managed processes of stage 4 in our model to a stage where we are constantly optimizing these processes? What can we do? So we've already established a repeatable, defined, and a manageable security operations practice by now. And this is what we now need to optimize. Well, to do so, we have some key priorities to look at. We are now at a stage where we know the kinds of actions and responses required within our incident response playbooks. Those actions are going to be repetitive, possibly even dull, now or becoming so, and are taking up analyst time that could be better spent on actual analysis or proactive threat hunting, that kind of thing, for example. So such repetitive actions are ideal candidates for automation, which is our first key priority. And our next priority is to orchestrate our security tooling in order to simplify the incident response process. So whilst it may not be the case that a SIEM platform is in place, whilst it may be the case that a SIEM platform is in place, providing centralized alerting, analysts may still be required to interact with a variety of disparate systems in order to respond and recover from a detected incident. So orchestrating security tooling from a single platform, such as a SOAR platform, will provide many benefits in those processes, not least in analyst time saved, machine speed, incident response times, just to name a couple. But both these automation and orchestration methods that we've discussed so far, these are tools that will allow us to improve on key metrics such as incident response times, false positive reduction, risk acceptance as well, but also the overall cost-benefit ratio of the security function. And additionally, we also want to concentrate on implementing more advanced detections within our SIEM at this point. So taking advantage of our large amounts of normalized data and performing more and more sophisticated analysis upon it for better insights into our security posture. And we're also going to be increasing the likelihood of detecting anomalies that might typically be missed. And here again, we can see the Splunk Security Data Journey, another model focused on data collection, in particular for the SIEM function, and extracting value for that data, a topic which Ben spoke about at some length in previous parts. However, we do now find ourselves at stage 5 and 6 of this model. And from here on in, the SOC's mantra should be optimize, optimize, optimize. So at stage 5, automation and orchestration, this involves the establishment of a consistent And repeatable security operation capability. Well, we are, or should be, at 5 years already at this point. And our response plans are most likely tried and tested in the majority of cases and have been proven to be robust and repeatable. This now opens the doors to the possibility of SOAR technology. Splunk's offering, of which we'll dive into shortly, with a quick demo of some of the features, and which should now be utilized where possible and appropriate as well. And next at stage 6, we have advanced detections. So applying sophisticated detection mechanisms, including machine learning at this stage. And such advanced detection should provide visibility over anomalies that would normally not be possible to detect using the more traditional techniques. Okay, so now for a quick demo of Splunk SOAR. I'll show you how it will automate and orchestrate as per stage 5 of the Splunk security maturity journey, and also how it will help optimize your security processes. So this is the login screen. We'll just log in now. And the first screen we get to actually is the home one, and it's a dashboard displaying various pieces of information on metrics. So it's showing information on those on the measurable aspect of those processes that we'll be looking at. We've got such thing as SLA type information, return on investment stats, performance, that kind of thing. So yeah, we're taking advantage of the measurability of our processes here. Okay, but I think to start off with, we'll look at the orchestration aspects of this, and that is achieved within Splunk SOAR via apps. So we can reach that here, home and apps. And it's best to think of an app as a connector to a device or service that you might be using, which will allow Splunk SOAR to connect to it, typically via API, and perform actions from this platform. And you can see here we've got some configured and unconfigured apps. If you just take a look at some of the configured ones, Virus Total is always a good example. So here we can see Virus Total. This is one of the apps we have. So this is a connector to the Virus Total service. And if we look here, we've got 9 supported actions. So let's take a look at that. And these are the kind of things we can do. So designated URL, designated a file. Obviously, this is dependent on the type of service you have with Virus Total, but IP reputation, URL reputation, all that kind of thing there. But test connectivity at the bottom, that's a configuration action. Now, all of these action names are uniform across services or apps. So if we have a different service other than Virus Total, Fish Farm or something like that, a URL reputation check is still called a URL reputation check. And that makes it really useful for when it comes to the automation playbook side of this, which I'll show shortly. So yeah, these are the kind of actions we can do by one example. Underneath here, you might also notice we have one configured asset. Now, an asset is the service itself. So if we click on that, we can see that we can see that information has been given to the connector to the app to allow it to connect. So we've got an API key here, for example. Another one. Let's look at Zscaler. Another one that's set up. So again here, this time we've got 19 supported actions. Quite a few more on block URLs, IP addresses, that kind of thing. Everything you might expect from Zscaler. Really, if the API of the service allows you to do it, then we can expect to see an action here. But it's also worth mentioning, though, if you are using a device or service where the action isn't present, but the API can do it, all of these connectors they're hugely configurable. So you can download them. And they're all written in Python, and you can just add an additional function as required, and it will give you that extra action if needed. So yeah, we can configure these apps. Failing that, if there just isn't one at all, you've got something bespoke in-house built. There is actually a framework. So App Wizard here on the top right. This will provide you with all the boilerplate code that will be required to communicate with that device, providing it's got an API. You just need to provide the specific functions and actions for it to do it, the logic behind that. But yeah, it's a really configurable platform for orchestrating your security devices and services, which is what these connectors or apps are all about. Let's just take a quick look at the documentation bit here. So you can see that here. If we click on that, you can see a fairly rich selection of documentation that's telling us exactly what an action requires and what the output of that action would be. So let's just take a look at block URL. A supported action there. Click on that. It should take us to the line, but it hasn't this time. So block URL, we'll find it. Here we go. So here's our action, block URL, and we've got some information here on the parameters, what it's required. So unsurprisingly, it requires a URL or a list of URLs, and the output here. This is what, once it's performed that action on the URL, this is what we can expect to see after it's done it. So things like descriptions, the status of the action, that kind of thing. Now, this is also important when it comes to writing the automation playbooks, because we want to know what an action would need and what the output of that's going to be. So if we just take a quick look at virus total, for example. URL reputation. It also requires URL, but this time we've got selection of positives. So we've got some items such as positives. So this is probably something we're going to act on, maybe, which we'll see later if we want to block a URL. We'll be interested in what the output of that check reputation is, and we'll look at here and what we want to use. So probably in this instance we're going to be looking at positives, and we'll use that further for further actions. We can pass that down. We'll see this shortly. Okay, and the only other thing really to mention is these are the configured ones. Apps that aren't configured, there are many technologies here as well. If we just pick one, Palo Alto, we can see the actions that this app allows us to perform with that. And if we want to configure one, we configure new asset here. Provide it with the information such as asset settings. This time we want an IP and username and password. And there are various other things we can control as well, such as approval settings and access control. These are topics that I've gone into in different webinars, which I invite you to take a look at. So yeah, these are connectors, these are the apps, this is the orchestration, this is how we orchestrate from this single platform. Now let's just take a look then at how that actually takes place. So if we look at some sources, now our SOAR platform, it obviously needs events to act upon, and we can see these here in sources. So if you have a service such as Splunk, it can generate events in the form of alerts. When alerts are triggered, we can configure Splunk to send that information JSON formatted to this platform. And then the information within that object that's been sent, we can then use that to act on. But it's not just Splunk. It can be any service, device that generates events or any kind of information really that can be sent and read and acted upon. So for example, here we've got a lot of Splunk events, but we can also see we've got things like email, which we'll see shortly. Yeah, email. So this is configured with Office 365. If someone reports an email's potential phishing, we can send that to SOAR, and we can do that initial triage piece on this, which is something we'll look at now actually. So someone's obviously done that in this environment. Is this a phish? Calling your employees. That's been forwarded. That's been reported and forwarded to this platform. So we'll take a look at that. This is the screen, the investigation panel that we'll see when an analyst first clicks on an event on the source screen. We've got a timeline here. On the left, we'll see it populate. It's a list of activities that are done against it, and widgets as well. So depending on the connector we're using or the service or the application, if we do a URL check, it will give us information on that. If we do a screenshot, we can see that information here as well. So it'll all populate underneath here, but it's also all recorded on the left. So looking at our phishing email, we clicked on artifacts. For now, just think of an artifact as a piece of information within the event. And we can see here, this artifact, a phish URL artifact. Okay, interesting. Let's take a look. And we can see details of it here. Request URL. It's splunk.com, spelt slightly wrong there. /password reset. Okay, pretty suspicious. What do we want to do? Let's check the reputation of this URL first of all. And we can do that from here. We don't have to log into Virus Total onto the website. All these actions take place from here. So we just click on that downward arrow. We want to run an action. Let's do reputation. Start typing in. We can see that these actually change as it searches. So we've got one reputation option here, URL reputation. It's aware of the type of information it has. Okay, so this request URL, this is actually a specific field name, which I do also cover in a different webinar. But essentially in Splunk, we use SIM field naming, so source_IP. Here it's CEF, common event format, and it's camel case. That's the main difference. But anyway, let's click on our URL reputation. List of assets here that we can use. Let's use virus totals. We've taken a look at that earlier. Click on that. We've got the URL. It's already populated that we want to check, and just press launch. So now at the moment, Splunk SOAR, it's via the application. It's making a request to the virus total API, and it's returned some information for us here. We can see it tracking it on the left. We've got 71 scans. We've actually got 3 positive results here. So there are 3 reports that this is a dodgy URL. What do we want to do next? Okay, well, we're probably going to want to block that. So let's do that again. We've got Zscaler set up here, so we can do that via Zscaler, as we saw earlier. We know from the documentation that it requires a URL, so we're happy we can do this. So click on this again, run action, this time block. Okay. And if we look under our contain section, apologies, type in block URL. Let's do that. As before, it gives us a list of assets. This time we've just got Zscaler. Before we had several we could have picked. This time just Zscaler. Yeah, that's the URL we want to block. Launch. You can see on the left here, it's doing it. Yeah, great. We've now blocked that URL. So we've done all these actions from this platform, this single point of contact with all of our security services and devices within our estate. So clearly, I think it's fairly obvious, this is saving time, and we've introduced some efficiencies here, and we've optimized this specific process. We can take it further. So this is still fairly manual in a way, but if we now take a look at playbooks themselves, these are automation playbooks. And this is really the meat behind this, the platform. So if an event comes in with a particular label, we can see here, so events or email, we can write playbooks that will automatically trigger when that event reaches this platform. Okay. So let's have a go at writing one now. We can do that pretty quick. So just plus playbook, top right, automation. Let's give it a name, my phishing playbook. Give it a setting as well. I mean, operates on. So this is the label. So if we have events coming in to this platform, when they come in, we give it a label. So the email one we saw earlier, that would have the label email. It's just a piece of metadata that's attached to it. So if we want this playbook to automatically act each time against events with the email label, we select that there. And we would collect it to be active if we want it to be automatic all the time. We won't do that now, but that's how we would do that. Okay, we'll just save that briefly. Yeah, just for example there. Okay, and then we're good to go. So we've got a start block and our end block here. So this is where, if we imagine the event first arrives at Splunk, it hits this function. All these blocks are just Python functions or methods. So at start, the event comes in. What do we want to do first with our phishing email event? Well, we're going to do the same kind of triage that we saw earlier, but this time we want to automate everything. So that is going to be an action. We drag the action down, and we pick what action we want to perform. So as before, we want to do a block URL. So we can pick it by app. So we click virus total, for example. We can pick it here if we know the apps. If we know the action, we can just go block URL. We can see it here, and then it lets us pick it that way. But obviously, at the moment, we are doing a URL reputation. Click that. Let's do virus total again. What information does it need? artifacts, request URL. It's already aware of what it needs, so we click that. Brilliant. And let's drag an arrow coming from here to here. So the event comes into the start block, and we've got our flow via this arrow, and it reaches this action. And in that event, there's a field called request URL, which we've already seen, and it's going to perform the URL reputation check. Brilliant. Okay, so what next? Well, there's a few other things we can do after that. We can call another playbook. We can utilize some of our own custom code. If there isn't a function available within Splunk SOAR, we can configure it out ourselves. Utility, we can interact with the SOAR platform. So it's got a fairly rich API, and we can do such things as raise an event to a case, for example. There's quite a lot we can do there. Add comments, add tags. Filter and decision, these are like our if, else, and that kind of logic, which we're going to have a little look at here. And then format blocks, these are quite important actually. We can format strings to send to other assets. So for example, if we have Splunk configured as an asset, we can format a string, a search string, an SPL, using pieces of information that are generated by the actions previously performed upon the event, send that to Splunk, run a search, and then come back. We've got a load more information there, which we can perform further actions on. So the format string, that's pretty cool. Or we can use it to send emails, that kind of thing. Or a prompt. Maybe after we've done our URL reputation, we want to get a person to take a look at this. Or we can do that by a prompt. Drag and drop that block. Someone will check it if we want to do that. We're not going to do that now. Let's do a filter block. So we drag our line across to here. What do we want to filter on? So if we're going to use the results of our URL reputation check. So that field there is what's been passed down from the URL reputation check there. It's additional information on our from our action earlier. And we saw already positives. So if a URL has previous reporting upon it being malicious, we know that would appear in our positives field. So we click on that. And let's say equal to or greater than 1. If anything's reported as negative, we'll let that pass. Okay, we're done. Next, we want another action. We want to block it if it does pass that filter. As you can see, we can drag and drop from there. We can pick our symbol rather than drag and dropping from the left. So action, by action, block URL. Hopefully you can see here why there's a standard name formatting for all these actions. Block URL, we pick Zscaler. It's going to be from the filter and the URL. We're going to pass it the filtered URLs that have come through from there. That's going to get blocked, and then it ends. And that's really how simple it can be. Now, obviously, at this stage, as we've discussed, our processes are going to be, refined and honed. We know what they're going to be. So this really should be quite a simple process. Really, we're just digitizing what we already know. We just need to break those actions down into specific, discrete tasks, which is no difficult task if we're familiar with our processes. And that's how we do it. We would click save there, and then we would go back to our sources, and we would be safe in the knowledge that this would trigger automatically. Now that's a fairly crude example, just to give you an idea of how complicated and sophisticated it can get. If we just look at an example of here's one I made earlier. Always wanted to say that, of course. Loading playbook editor. Yeah, and look, this is how detailed they can be. Okay, so let's we'll zoom into that a little bit and just show you and talk through it real quick. Yeah, event comes in. First of all, file reputation and then a URL reputation check. We're going to do those in tandem. Logically, these in tandem, but in reality, it is a single-threaded process, so it's going to be that one first, then that one. But logically speaking, happen at the same time. Then we've got some decision blocks based upon the information provided there. Maybe we're going to detonate in the sandbox, look for the file, is it anywhere else in our system, get a screenshot of the URL, all that kind of thing. And if all of the planets align and we're not happy with it, let's get someone to take a look, block the URL, etc. Call another playbook, so we can call a playbook from this playbook. And this one here is delete phishing email, and then it comes to the end. So yeah, all of that stuff we can automate. And if we actually run that, so we go back to our sources. is this a fish? Do this one again. Got our artifact, we've got our URL. Let's actually call that playbook from here. So we can do that. We can run actions as you saw earlier, but we can actually call an entire playbook. So if we call the sophisticated one, run that. Look, we can see all the tasks running to the left here. You know, they're whizzing through it. They're tearing through all these different tasks. Clearly, this is going to save a lot of time and effort. It's a process that we can almost entirely automate. And then it does get to a point though. We can see we saw it in the playbook earlier, where there was a human prompt. Here we are. We're prompted here. Phishing email detected. Delete the email. Yes, delete that email. Complete. There we go. So then we still got the human touch, but I think it's clear to see just how much time and savings that can be made on this. This is a good example of an optimized process. Okay, so yeah, that really concludes that that demo for us there. What I'll do now, I'll move on to some of the more sophisticated detections we can take a look at, advanced detections, and to do that we'll just switch to a different platform, which we can see here. So this is a Splunk instance with the machine learning toolkit installed, along with several other supporting apps. So we will first of all, we'll go to the machine learning toolkit app itself, and then we can see we are at the showcase section of the app, where you can find dozens of examples of how to leverage machine learning to address practical use cases within your organization. So these can be viewed by 4 categories here. We have predict fields, detect outliers, forecast time series, and cluster events. Alternatively, the samples can be viewed by different industries. For example, we've got security just here. So clicking on one of the categories shows us all of the available examples in that category, labeled as IT or security use cases. They can also be sorted by smart prediction, predict number numeric fields, or predict categorical fields. Every example includes sample data and pre-built models here that you can walk through. Going through these examples are actually a great way to learn how to use this particular tool, and it can also help you get ideas for potential use cases that you can apply yourselves. In addition to these examples, you will notice links to the docs and video tutorials on the menu bar. Yep, these are really good. Like other Splunk documentation, it's pretty extensive, and it's a great first step to get any questions answered. The smart assistant examples are the easiest place to begin, since they can be used by users. If you don't have much SPL knowledge, start here. So let's now take a look at the predict disk utilization example. So this is an IT use case, but it's actually useful as a demonstration. So this opens the Smart Assistant experiment interface. It is separated into 3 main steps. So we have, first of all, define, then learn, and then review. And so in step 1, define, we need to define the data that we will build our model from. You'll notice the search field is pre-populated here with the search to load the data needed for this example. So if you were doing your own experiment, you would enter your starting search here. And note you can also choose data sets or use metrics to start pulling the data. Next step in the process is having Splunk learn about the patterns in the data and to build a model. So the top option here allows you to add a pre-processing step before building the model. For example, if you had a large number of variables or predictor fields, some models will perform better by reducing them to a smaller subset. One method for doing this is called principal component analysis, or PCA. But since our example didn't configure a pre-processing step, we'll continue without them. But these examples provide more opportunities to try different options, see what their impact is. So next, you identify the value you want to predict. So remember, this is an example of predicting a numeric value. If you're building from scratch, you'd have to select the desired field here. But yeah, this has already been done for us. Next, you'd identify the predictor fields, those variables that you want to find the patterns within in order to predict the target variable. So in this case, there are only 2 selected. You'll notice the assistants do give you options for tuning the algorithm as well. If you hover over the question marks next to each parameter, you can get a bit more information to see how it's used. The last option we need to set for generating the predictive model is what percentage of the records to use for training the model and what percentage to use for testing. So by not exposing the algorithm to all of the data during training, you can see how well the model will generalize against cases it hasn't actually seen before. So it's a good testing bit. And it's also useful for to avoid overfitting the training data. And a common practice is to use an 80-20 split. So that's what we'll do here. And then we're going to click the predict button and see how it does. So it can take a bit of time. But on the right, you'll see two metrics about how well the model's performing. So we've got the R squared and the root mean squared error. So for the R squared, the closer the score to 1 is, the better. And we can see here we've got an R squared of 0.998 on the training data anyway, and 0.9934 against the test data. So clicking on the scatter plot button, that shows the prediction dots tightly hugging the line. So that's the straight lines representing perfect predictions there. But it's worth noting, in a real world example, any R squared that close to 1, it's probably too good to be true, and the data's probably been overfit. Okay, so now we'll look at the RMSE. Since there is a much larger error when used against the test data, that also raises concerns about overfitting as well, actually. Were this a model we were actually developing, we might want to get a large data set here. But there's some good indications to tell us how well it's doing. So while the smart assistants don't actually require using SPL, clicking the SPL button here, it shows you how you could have accomplished the same thing for a basic search using the fit command. Other examples in the toolkit allow you to see with greater detail how to use fit, applying a score to develop models outside of the user interface altogether. And finally, we come to the predictor importance screen. So here we can see how influential a variable was in predicting our target. So using this information, we might want to revise our model and drop less relevant variables from future iterations, for example. Okay, next we can see the experiments view. This is where you'd go to begin creating your own models. So you can see we have one experiment here that similarly predicts disk utilization. However, clicking on the Manage dropdown, where we see additional options that are available to operationalize our models. So first, you can see create alerts based on the results of predictions, enable your teams to be, proactive in response to those predictions. Second, we've got models that can become less effective over time and typically they need to be retrained. And the machine learning toolkit allows you to actually schedule this to occur on a repeated basis. You can make that part of your process, and it ensures that the models continue to reflect reality as well. This is really important for security use cases, of course. Okay, this has been a really quick look at the machine learning toolkit, but you can install it yourself in your environment and have a good look around yourself, experiment, play. It's free to download. And there are other apps of interest installed here too. You can see on the left we've got the deep learning toolkit. So this actually provides sort of tight integration between Splunk and common data science platforms, Jupyter Notebooks, TensorBoard. But you can also you can leverage GPU as well, GPU compute, bring some performance boosts to model training, things like that. It's quite interesting. We've also got some others as well, some security use cases. We've got some DJ and botnet apps here. So these are great security starter apps for MLTK. You can learn from and learn how to apply the capabilities of the toolkit to address more security use cases. And so this brings us to the end of this Splunk webinar series, A Journey Through Security Maturity. We've looked at how organizations' processes map against the capability maturity model, going from level 1, ad hoc and disorganized, the first year generally of developing the security function for an organization, and how, with Splunk, they can mature to the 5th level and implement a continuous program of optimization. We've also seen how this maps to the Splunk security maturity journey, the 6-step process from initial data collection to the application of advanced use cases and automation. On behalf of Ben and I hope it's been a useful series for you. And if you happen to have missed any of the previous parts, please explore our YouTube channel, which is detailed on the screen now. And please do feel free to contact us with any questions at info@somerfordassociates.com. Thanks again for joining us.